Guys, welcome back. So what we're looking at today is lesson 13. Now this is from unit 4. So we did unit 4 earlier in the year. It was the very first workbook that you guys had. So we are back in that. So if you did save that workbook, then you're looking at lesson 13 and 14 today from that. If you did not, no worries. I have the PDF of the practice problems on our week 10 page. So you can look off of that for taking and doing your practice problems. You can either print that out or look off of it and write it on a separate sheet. For those of you when you're in person, you will get a copy of the practice problems printed out for you. So if you want to wait until then to do it, you can. That is completely possible. Otherwise, this is what we're working on. So unit 4, lesson 13. So what we're looking at here is areas of squares and rectangles. So we're using a piece of 1/4 inch graph paper for the following. We're going to use a ruler to draw a square with a side length of 1 inch on the graph paper. Inside the square, draw a square with the side length of 1/4 inch. How many squares with a side length of 1/4 inch can fit in a square with side length of 1 inch? So let's go to the graph paper. We're going to take and have an inch side. So there's an inch by there's an inch by an inch square. So let me get this part drawn up and over. Okay, so we have our 1 inch by 1 inch. So this is 1 inch and this is 1 inch. Now it wants us to draw a 1/4 inch square. Well, this right here, down in the bottom down here, is a 1/4 inch square. So it asked us how many squares with side length of 1/4 inch can fit in a square with side length of 1 inch. So count up the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 squares. Now, what's the area of a square with the side length of 1/4 inch? Well, if the area of the whole thing is 1, because 1 times 1 times 1 equals 1 inch squared. So the whole area of this square is 1 inch squared. And if one of these is what we're looking at the area of, and there's 16, the area is 1/16 inch squared. Now, we can also find that by multiplying. So we don't necessarily have to draw out a square using the graph paper with measurements and then see how many of those are going to go in there. We can also do it by knowing, okay, 1/4, so 1/4 times 1/4. Remember, when we deal with fractions, we multiply across the top. So 1 times 1 is 1. And then we multiply across the bottom. 4 times 4 is 16. So we get the same answer. So you can do it both ways. The next one, use a ruler to draw a rectangle that is 3.5 inches by 2.25 inches on the graph paper. Write a division expression for each question and answer the question. So let's get this drawn out. So we're going to have, see, it says 3.5 by 2.25. So 1, 4. Okay, so there is our 2.25. Now we'll do the 3.5. I'm 1 short, so we're going to pretend that extends out there. This. Okay, so here is our 2.25 by 3.5 inch. Oops. Obviously not very straight, but you get the idea of it. So 3.5 by 2.25 on the graph paper. Write in a division expression for each question and answer the question. So how many 1/4-inch segments are there in a length of 3.5? Well, how would we take and write a division equation for that? We'd take the whole length, so the 3 1/2, and divide it by 1/4, because we want to know how many 1/4 go into 3.5 equals question mark. Now, we can solve this using same times flip. We can also check by counting here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's going to be 14 1/4 inch squares. And you would have got the same answer by doing same times flip here. For B, how many 1/4-inch segments are there in a length of 2.25 inches? Well, same idea. 2.25 divided by 1/4 equals question mark. This one we're going to do same times flip. So 2 times 4 is 8 plus 1 is 9. So we have 9/4 times, we flip the 1/4 to 4/1. Our 4's can cancel, so we're left with 9/1, or 9 1/4-inch squares. And if we go back to this, we could see 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9 1/4-inch squares. So we got that right. So we can use our drawings to show that 3.5 inches by 2.25 inches has an area of 7 7/8 square inches. So if we go back to this, we have our 2, and this is where the 1/4 is. Obviously not a very straight line. 1/4. And then we have our 3.5. So 2 times 3 is 6. So this is all 6 right here. Here we have a 1/4, and here we have 1/2. So multiplying a 1/4 and a 1/2 together is, or multiplying 3 times a 1/4. So 3 times 1/4. This is going to be 2 times 1/2. And this is going to be 1/2 times 1/4. So this right here is going to give us 1/8. This right here is going to give us 3/4. And this is going to give us 1 whole. So 6 plus 1, that's going to get us 7. And then 3/4 plus 1/8 is going to get us our 7/8. So that's how we can kind of see that by drawing that out there. Okay? So that's what you guys are looking at in this lesson, is all fractional lengths when we're finding the areas of rectangles and squares. Okay? Now we're going to look at more fractional lengths, but lesson 14. And now we're looking at other figures. So bases and heights of triangles. The area of square B is 8, or triangle B is 8. Find the length of B. So we know the area is 8. We know the height. We're looking for the base. So 1/2 times the height times the base equals 8. So if we multiply 1/2 and 3/8 together, we're going to get 8/6 times B equals 8. Now, in order for this to equal 8, we need to take and divide by 8/6. So divide by 8/6. So remember, same times flip, 8/1 times 6/8. We flip the 8/6. The 8's cancel, so we're left with just 6/1. So that means our base has a length of 6. All right, for 2, the area of triangle C is 54/5 square units. What's the height of H? So 54/5 equals 1/2 times the height times the base, which is 3 3/5. And the 3 3/5 I'm going to convert right away to my improper fraction. So 3 times 5 is 15, plus 3 is 18, so that's 18/5. So times 18/5. So 1/2 times 18/5, we're going to get 18/10 h equals 54/5. Divide by 18/10. Divide by 18/10. So same times flip, 54/5 times 10/18. Now we can simplify these down. The 5 and 10 cancel. This becomes a 1. This is a 2. I apologize for all the strange lines everywhere. It's a 1. It's a 2. The 54 and the 18 can cancel. They are both divisible by 6. So we end up with 9. They're actually divisible both by 9. 54 divided by 9 is going to give us 6. Let's see. So, wait, they're actually 54 divided by 18. They're actually divisible by 18. They're both divisible by 18. So we can cancel these out. 18 divided by 18 is 1. 54 divided by 18 is 3. So now we have 3 times 2, which equals 6, over 1 times 1, which equals 1. So our height over here is 6. So we can take and solve for these things. You have to be careful, though, when we're solving for a missing side in a triangle because of that 1/2. So you have to remember you have to take into account that 1/2 when you're taking and solving. So writing it out with what you know, what's your area, what the 1/2, and then either your base or height, depending on what you have, and then solving through to find it. Very beneficial. Okay, the last part of this is looking at volumes of cubes and prisms. So here we have some cubes. They have an edge length of a 1/2 inch, and we're going to use them to answer these questions. So here's a drawing of a cube with an edge length of 1 inch. How many cubes with an edge of a 1/2 are needed to fill this cube? So it's going to take how many cubes to make up one side of this figure? So if it's 1 inch across and each of our cubes are a 1/2, it's going to take 2 cubes to make each of our dimensions. So it's going to look something like this. So here is our cube. Remember, each of these cubes is a 1/2. So when we put them together, now we have 1 inch by 1 inch by 1 inch. So it's all 1 inch around here, just like the cube there. Now what it wants to know is how many cubes are needed to fill the 1 by 1 by 1 cube. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 cubes in here. So it takes 8 1/2-inch cubes to fill this 1 by 1 by 1 cube. So this 1 inch cube. So for part B, what is the volume in cubic inches of a cube with an edge length of 1/2? Well, same as before, one of these cubes, it takes 8 of them, so it's 1/8. We can also find that by multiplying. 1/2 times 1/2 times 1/2. 1 times 1 is 1 times 1 is 1. 2 times 2 is 4 times 2 is 8. So 1/8 inch cubed. So we can do this without having to use these cubes. It's all about multiplying, but you have to take into account how many it takes to make up some of these dimensions. So this next part here, 4 cubes are piled in a single stack to make a prism. Each cube has an edge length of a 1/2. Find the volume in cubic inches. So if each of these are a 1/2, we've got a 1/2 by, there's 1 inch, there's 2 inch, so by 2, by a half. So